Welcome to AFR Space. This is my level 1 certification vehicle, Aurora. It flew to about 1,300 feet on an H550 with an 8-second delay. There are some design considerations on this rocket that I wish I would have changed. I'll go over those in a bit. But for now, we're just going to go ahead and get into the fin can. The fin can has a 3-inch outer diameter tube that is made of cardboard and an inner 38 diameter tube that is for the motor mount. Each end is capped with a 3D printed bulkhead that is epoxied into the outer shell and onto the inner motor tube. These hold the motor tube center in the outer tube and then have hooks on them to help me epoxy the fins to the motor tube. The fins go through the outer wall and in and epoxy to the motor tube, and then the outer motor tube has slots cut into it that then get set down over it, and then we put epoxy fillets around the edges of the fins. These fins are 1/4-inch birch plywood, probably overkill for a level 1, but you know, why not? My favorite part about this is the 2 camera pods on the side. I probably could have gotten away with putting one, but I wanted it to be symmetrical, and one change I wish I would have made is I wish I would have made one pointing up, because you can't really see any of the deployment. You get to see the nose cone flying away. It suffered a quite tremendous fall from about 1,300 feet. When the deployment charge went off, the separation event was so violent that it ripped the hook out of the bottom of the tube. This led to it tumbling to the ground quite violently, and you can even see in some of the onboard footage as it violently whips around from the deployment event. You can watch as the nose cone is tumbling away, and you can see where the quick link where it should have been attached to. Another design consideration that I wish I would have considered is that in these camera pods, I did not glue the cameras into place. I was relying on a fiction fit. So when the ejection event happened, it actually popped one of the cameras up out of its mount, and you can see that because it's a reduction of field of view. Alrighty, let's talk a little bit about these camera mounts. The camera mounts are a 3D printed design that I just quickly catted up in Fusion. They are then epoxied to the outer wall of the body. One thing I wish I would have done is I wish I would have epoxied these on before I did my fillets for the fins, because they kind of sit out a little bit because of that, and I had to fill in quite a bit with epoxy. They have a hole in the door for a screw switch, which is a switch that conducts electricity once you screw it down. They're pretty resistant to vibration and are pretty common on rockets. The electronics inside of these are pretty simple. They have a buck converter, the camera, and a 9-volt battery. The buck converter drops the voltage from 9 volts down to 5 volts for the camera. It's an interesting schematic though, because when you have the battery plugged in, the buck converter is always on, and the screw switch cuts power to the camera itself. The reason I made this design decision is because it was unreliable on startup if I were to go from the battery to the buck converter. I believe this is because the buck converter did not start up very cleanly, and it would cause the camera to not boot nominally. Alrighty, well, thank you for watching. If you like the videos, go ahead and subscribe. I'm going to try to put out more videos. My next rocket launch is going to be in a few weeks, and it will be launching a fiberglass vehicle. So I look forward to that coming up in a week or so, and thanks for watching.